Hi everyone, this is the power focus area called inferences from data, and we're on objective 1, which is all about this thing called standard deviation, and we're going to use that a lot in this objective and the whole power focus area. This first box up here is the definitions for these words mean and standard deviation, and then I have a little remember, which is a keynote about those things. So I have a whiteboard with all of these definitions on them already. So if you want to pause the video right now and copy the definition of mean, which is in blue, and then the definition of standard deviation also in blue, and this last little keynote in blue. I would copy these three things by pausing the video. Okay, so the mean, hopefully this is review, but it is the average number of a set of data, or it's the center number. Standard deviation, this is how much you can vary above or below the mean. So the mean's your center, this is above or below the mean, and I'll show you what that looks like in a second. And then my keynote is remember that the smaller your SD is standard deviation is, the smaller your standard deviation is, the more reliable it is. We're going to use that word reliable. Okay, so let's look at our first example. I'm telling you here in red that your mean is 70. Remember, mean is the center, okay, 70, and then your standard deviation is 4. So when I ask you what is your spread, what that looks like is you have 70 as your center number, okay? Then standard deviation, remember that can be above or below, is 4. So that means if I would go 4 below 70, that is 66. It's just 70 minus 4, 4 below. And then if I go 4 above 70, that's 74. So my spread here is going to be from the number 66 to the number 74. That's how much this data varies. It can vary between 66 and 74. Okay, so let's look at this now when we have word problems. So my first example for you is Josh scored 2 standard deviations above, okay, above the class average on his Algebra 2 exam. The class average, or the mean, okay, was 75 and had a standard deviation of 3. So what did Josh score? Okay, so my mean, or my center, is 75. That was the class average. And the standard deviation is 3. So that means it's going to go up by 3, so above, or it's going to go down. So 75 minus 3 is 72. This would be 1 standard deviation above or 1 standard deviation below, because you can go both ways, okay? But remember, our problem said that Josh scored 2 standard deviations above. So we only went 1 above, so we did 3 above. Now let's do 3 again. So let's add 3 for our second standard deviation. So what is 78 plus 3? That's 81. So Josh scored an 81 on that exam. Okay? Example 2. The average number of hours spent sleeping for a teenager is 10, with a standard deviation of 1. Nate only sleeps around 6 hours each night. How many standard deviations below the average does Nate sleep? Okay, let's break this down. So our average, or mean, is 10, right? So that's our middle number. And then our standard deviation of sleep is 1. That's what our problem says, 1. So that means every deviation is up or down by 1. Now, Nate only sleeps around 6 hours each night. So Nate's sleeping 6. How many standard deviations is that away from the mean? Remember, we're only going by 1. So if I would go 1, that's 9. Another 1, that's 8. Another 1, 7. And then we hit 6, right? So that's 1, 2, 3, 4. That's 4 standard deviations away from the mean, okay? So you're gonna have a lot of word problems on this PFA, all about your standard deviations. Next, you're gonna have some graphs, okay? So I gave you a blank graph and you're gonna draw a little picture for me, but let's see what I want from you. So we're gonna graph, well, first what it says is that graphs with small standard deviations or that little variation are narrow because your data is all around the middle, right? This one had a small standard deviation of 1, so the numbers were all very close together. Makes sense. So my graphs can be very close together, okay? Graphs with large standard deviations or that high variation are wide. They're far out because the data can be far from the middle. So what am I asking you to do? On the graph to the right, draw a graph with a small standard deviation, a graph with a large standard deviation, and a graph with a standard deviation in between small and large. Okay, seems pretty easy. Well, let's try it. So again, I'm going to have this whiteboard, and I'm going to use 3 different colors to kind of show the differences, okay? So the first question said, draw me a graph with a small standard deviation. Okay, I'm going to do that one in black. So a small standard deviation is going to be skinny because all of your numbers are going to be very, very close to that middle, that mean, or that center. So this is pretty skinny, okay? Let's do, the other one was saying, other question said, what about a graph with a large standard deviation? Okay, so large means that they're really far apart. So that's going to look something like this. So here's my center, and the numbers are very spread out because their deviation from each other is large, okay? And then my last question said, okay, now draw me between small and large. Okay, that's pretty easy, right? I'm gonna use blue for this last part, but all it has to be is just a graph that's not as skinny, but not as wide as the red and black, okay? So you're gonna have a question on the PFA asking you to do smallest to largest deviations. Just know what they look like, all right? Last one, the kind of question you're gonna be asked are just knowing what it means for these deviations to be true or reliable. So you're gonna have, again, word problems. So let's look at example 1 here. So it says, if Tiara takes 25 minutes to walk to school with a standard deviation of 5 minutes, and then it takes Marlene 30 minutes to walk to school, and then her standard deviation is 10 minutes. Okay, what's the question? Whose travel time is more predictable? Predictable can also mean like reliable. Whose can you count on? Whose is more reliable? Well, remember back to our definitions, okay, that the smaller your standard deviation is, the more reliable the data is. So in that word problem, did Tiara or Marlene have a smaller deviation? Tiara did, right? She only had 5, Marlene had 10. So that means who's more reliable to get to school? Who deviates less? Tiara. Okay, last one, we're almost done. Example 2, quiz 1 had an average score of 83% with a standard deviation of 12%, and quiz 2 had an average of 92% with the standard deviation of 7%. So which of these are true? Again, you're gonna get a lot of true and false questions about this, so you have to know what's going on, okay? A, scores on quiz 2 had a higher variability. So let's look. Quiz 2, remember, their deviation was 7, and then quiz 1, their deviation was 12. So which is higher, 1 or 2? 1, right? So that means that this was saying that 2 is higher. Not true, okay? B, a score of 85% could not happen. So, well, let's look. If I had a score of 83%, but I could go up or down by 12, then 85 is definitely up or down by, up by 12, right? You'll hit 85, so that's not true. And then quiz 2 is 92, but you can go up or down by 7, so you'll also hit 85 eventually. So that's not true. Okay, how about C? Scores on quiz 1 have a higher variability. Well, we already figured that out, right, from A, because quiz 1 had 12% deviation, but quiz 2 had 7, so quiz 1 is definitely higher. So that would be the true statement. Okay, a lot of word problems. Refer back to definitions and also these examples because there's ones just like it in the PFA. Good luck.